Hi, my name is Jimmy Chagoya, and my physics project is on the curve of a soccer ball, which I always thought was pretty interesting because it's one of the most exciting plays in soccer. I'm not very good at soccer, but I always thought it was cool to know. So I looked it up, and you can actually calculate the distance of the curve, the radius of the curve, and the distance that it was deflected. So to start off, the curve of the soccer ball depends on the to figure out the distance deflected. You have to know first the magnitude of the force of the curve. Magnitude of the force is represented through this equation, which all these variables right listed right here. The radius, small r, the spin of the ball, the velocity, the density of the air, which is also important, and the lift of the coefficient, which is experimentally determined. And so yeah, it's related into this equation right here, and the radius right here is cubed because it's a soccer ball, not a circle. So in general, when a soccer ball is kicked without other forces acting upon it, it goes in a straight direction. But because of the spin when it gets kicked, it has centripetal forces pulling it perpendicular to the kick, which results in a curve. So now to find the radius of the curve, you use this equation right here. Velocity squared over acceleration is equal to the radius of the curve. You know that acceleration is force divided by mass, and so when you substitute acceleration for force divided by mass, you get this equation. You can bring m to the top to get this right here for the radius of the curve. But when you plug in f, you get this big equation right here, and then you just do a little bit of algebra, bring the 3 to the top, the 16s multiply, and then you get this right here. The radius is equal to 3 times the velocity squared times the mass divided by the coefficient of the lift times 16 times pi squared times the density times the spin times the velocity times the radius squared. Okay, now that you see the equation, you can use different the different variables. Their factors can affect the radius of the curve. So for example, because spin is on the bottom, if there's a large spin, the denominator would get large, which would lead to a smaller radius. Since the velocity is on the top, if the velocity was a large velocity, this would lead to a larger spin, or a larger radius. Okay, so now that we know all this, we can calculate the distance of deflection, which is represented as yd, with the radius that we already know, and the distance of the kick. So when a soccer ball is curved, you can use a right triangle to draw and figure out the actual distance of deflection, with the radius here, radius minus the distance of deflection, and the distance of the kick. And so when you do the Pythagorean theorem, you get r squared is equal to the distance of the kick squared minus or plus r minus yd squared. And then when you do a little bit of algebra, you find the distance of the deflection of the curve.